Hello and welcome. This is chapter 12. We're going to be covering water and the major minerals. These are your learning objectives for the chapter. Water and body fluids. Water accounts for about 60% of an adult's body weight. Body composition influences how much a person's weight is fluid, lean mass versus fat. Water makes up about 75% of the weight of lean tissue and less than 25% of the weight of fat. So a body composition of mostly lean tissue may have a higher percentage of water. The proportion of water is generally smaller in females, obese people, and the elderly because of their smaller proportion of lean tissue. Water and the body fluids. I encourage you to pause just for a moment and try to answer it if you can. Water and the body fluids. In the body, water is where a lot of necessary life processes occur. For example, water helps carry nutrients and waste throughout the body, helps maintain structure of large molecules like protein and glycogen, participates in metabolic reactions, serves as a solvent for vitamins, minerals, amino acids, and other small molecules so they can participate in metabolic activities, acts as a lubricant for things like your eyelids, and as a cushion around joints and spinal cord. It helps aid in regulation of body temperature. For example, sweat evaporating from the skin helps remove heat from the body and maintains blood volume. So where can we find fluids? The first is intracellular fluid, and that's fluid inside of the cells. And it accounts for about 2/3 of the body's water. Extracellular fluid is fluid outside of the cells, and this includes both interstitial and intravascular. Interstitial fluid is fluid between the cells. Intravascular fluid is fluid within blood vessels. Distribution of body fluids. I encourage you to pause this for a moment and see if you can match the correlating sides. Electrolytes. When sodium chloride dissolves into water, it separates or dissociates into ions that are both positively and negatively charged. Cations and anions are electrolytes. Concentrations are balanced, so the number of positive and negative charges must be equal. The concentration of a solution reflects the amount of solute relative to its fluid. Solutes attract water. Osmosis, water movement across a membrane. Solutes, including electrolytes, attract water. Osmosis refers to the movement of water across a membrane to the more concentrated solutes. Proteins also attract water. We've talked previously about edema, which if you remember, edema can occur when protein leaks out of blood vessels and into space between cells and fluid accumulates. Osmosis. So in the image number 1, you see that water is just as likely to move in either direction because the solute concentration is the same. In the middle picture, or picture number 2, we see that more solute is added to side B, which increases its concentration. And in image 3, we see osmosis occurring because water moves to the more concentrated side. The volume of water is now greater on side B, but the concentration then becomes equal. Here are 2 questions for you. Again, I ask that you pause it just for a moment so that you can try to answer the question yourself before I reveal the answers. Regulation of fluid balance. Fluids maintain blood volume and blood pressure. This is regulated by the kidneys. The kidneys play a key role in regulation of blood volume and therefore blood pressure. The kidneys work all day to adjust the volume and concentration of urine based on the needs of the body and varying food and beverage intake. Antidiuretic hormone is a water-conserving hormone and it stimulates the kidneys to reabsorb water. Basically, the more water you need, the less you'll excrete. It also helps trigger thirst, which helps restore homeostasis. Drinking water and retaining fluids raises blood volume, helping restore homeostasis. The regulation of fluid balance. I ask that you pause the presentation for a moment and try to answer the question before I reveal the answers. Regulation of fluid balance. Renin is released in response to low blood pressure. It causes the kidneys to reabsorb sodium, which leads to water retention. This raises blood pressure and blood volume. In addition to sodium retention, renin hydrolyzes angiotensin to angiotensin 1. Angiotensin 1 remains inactive until another enzyme converts it to the active form angiotensin 2. Angiotensin 2 is a vasoconstrictor, which raises blood pressure. Angiotensin 2 also stimulates release of aldosterone from adrenal glands. Aldosterone signals potassium excretion and sodium retention. Therefore, less water is excreted. Renin, angiotensin, and aldosterone. Again, please pause this presentation for a moment and try to answer the questions before I reveal the answers. Fluid and electrolyte imbalance. So these are just some facts I'm going to share. So 1, sodium is lost indiscriminately by vomiting and diarrhea. Other causes of fluid and electrolyte imbalance are heavy sweating, burns, and traumatic wounds. Medical intervention depends on the circumstances surrounding losses. ORT or oral rehydration therapy is a solution of water, salt, and sugar to rehydrate after dehydration caused by diarrhea. Acid-base balance. So the body uses ions to regulate acidity. pH balance must be maintained within a narrow range to avoid life-threatening consequences. Deviations in either direction can denature proteins. Remember, a denatured protein can be rendered useless, which can potentially be life-threatening. Example, if we have hemoglobin that can't carry oxygen, or if enzymes can't catalyze reactions. 3 systems defend against fluctuations in pH. You have buffers in the blood, respiration in the lungs, and excretion in the kidneys. Acid-base balance. Please pause and try to answer the questions yourself. Regulation by the buffers. Buffers can neutralize acids or bases. Buffers in body fluids. Carbonic acid from carbon dioxide in blood. So carbonic acid is an acid, and you have bicarbonate, which is a base. These two act as buffers in the body. You also have respiration in the lungs. The lungs control concentration of carbonic acid by raising or lowering the respiratory rate. Respiratory rate increases, which increases the amount of carbon dioxide exhaled, which lowers carbonic acid concentration. If bicarbonate builds up, respiratory rate slows, carbon dioxide is retained, and more carbonic acid is formed. Excretion in kidneys. Bicarbonate is excreted or reabsorbed depending on if pH needs to be increased or decreased. Urine acidity fluctuates based on bicarbonate excretion or retention. Water balance and recommended intakes. So water losses include obligatory water excretion, so a minimum of 500 milliliters per day, or about 2 cups or about 1 pint. Obligatory water excretion is the amount of fluid needed to excrete waste generated from the body's metabolic activities. You also lose fluids through urine, vapor from your breath, as well as sweat. Factors like heat, humidity, and fever will affect how much fluid is lost. Thirst and satiety is sensed by mouth, hypothalamus, and nerves. The first sign of dehydration is thirst. Symptoms may progress to weakness, exhaustion, and delirium. Water intoxication is rare but can occur with excessive water intake and kidney disorders. Symptoms include confusion, convulsions, and possible death. Hyponatremia refers to low sodium concentration. Excessive water intake, maybe about 10 to 20 liters within a few hours, can dilute sodium concentrations in the blood, causing hyponatremia. The color of urine can hint at hydration status, but it cannot be used for diagnosis, as color of urine can change with presence of food dye, blood, or medications. Signs of dehydration, you can see with about 1 to 2% body weight loss, you'll have symptoms like thirst, fatigue, weakness, loss of appetite, vague discomfort, and then the more water is lost, the more severe the symptoms become. Water balance. So water sources include drinks, foods, and metabolism. Metabolism meaning the water produced from condensation reactions and the oxidation of energy-yielding nutrients. Water losses. Urine is typically the biggest output. Also, we lose fluid through sweat, breath, and feces. Percentage of water in selected foods. So water is obviously 100% water. Fruits and vegetables are mostly water, and then the list goes down from there. Please pause for a moment and try to answer the question. Water recommendations. Because water needs vary based on diet, activity, and environmental temperature and humidity, a general requirement is hard to establish. Adequate intake for total water is about 2 to 3 liters per day, or 8 to 12 cups. Needs vary. People who need more include active people or those who live in a hot climate. Best beverage choices. Water is ideal, especially with the obesity epidemic. Health effects. Water supports good health. Physical and mental performance depend on hydration. Dehydration can negatively impact performance. And proper functioning of kidneys, heart, GI tract, and other systems rely on adequate hydration. Moving on from water to minerals, this slide is an introduction to minerals. 1. Minerals are inorganic elements. This means they are not destroyed by heat, air, acid, or mixing. 2. Some foods contain binders that impact mineral bioavailability. Two examples are phytates and oxalates. Binders are chemical compounds in foods that combine with nutrients, especially minerals, to form complexes that the body cannot absorb. 3. Similar to vitamins, an excess of a mineral can create an inadequacy of another. Supplements are often to blame. 4. Some minerals are easily absorbed into the blood, transported freely, and are readily excreted by the kidneys. For example, potassium acts like a water-soluble vitamin. Other minerals must have carriers to be absorbed and transported. Minerals consumed in excess can be toxic. Other minerals like calcium act like fat-soluble vitamins and need carriers. Minerals in a 60 kilogram or 132 pound human body. Major minerals are needed in larger amounts than trace minerals. Both are still vital and one is not more important than the other. Major minerals. Sodium. Roles in the body. Regulator of fluid balance or regulator of fluid volume, acid-base balance, and nerve impulse transmission and muscle contractions. Sodium travels freely in the blood, and sodium is readily absorbed in the intestinal tract. Kidneys filter out and return what is needed. Normally, kidneys excrete about as much sodium as is consumed. Increased salt intake leads to increased thirst and therefore increased fluid intake. The kidneys then excrete the excess salt and fluid in urine. Sodium recommendations. You can see the adequate intake levels for adults. The UL is 2,300 milligrams per day. Deficiency is rare. Diets rarely lack sodium, and the body adapts by reducing sodium losses. So even if your intake is low, the body reduces sodium losses in urine and in sweat, thus making deficiencies unlikely. An estimated 90% of the US population exceeds recommended intakes. Sodium and hypertension. High salt intake correlates with high blood pressure and heart disease. Most sodium is consumed as salt, or sodium chloride. Dietary guidelines for Americans advise limiting daily salt intake to about 1 teaspoon. 1 teaspoon provides about 2.3 grams or 2,300 milligrams of sodium. And if you recall, 2,300 milligrams is the upper level or upper limit. For adults with prehypertension and hypertension, consumption of less than 1,500 milligrams of sodium per day is of even greater benefit. The DASH diet, or dietary approaches to stop hypertension, is an eating plan that focuses on reducing salt intake by incorporating fruits, vegetables, and low-fat milk products while limiting intake of salt, red and processed meats, as well as sweets and sugar sweetened beverages. Please pause the presentation for a moment and try to answer the questions before I reveal the answers. Sodium and bone loss or osteoporosis. High salt intake is associated with increased calcium excretion, but its impact on bone health is unclear. Potassium may prevent the calcium excretion caused by a high salt diet. DASH diet may help as well. Processed foods have the most sodium, things like pizza, soups, chips, sandwiches, tacos, etc. In fact, most sodium intake is from salt added to food during processing, not from salt added at the table or during cooking. Processed foods have two strikes against them because they are high in salt and low in potassium. Fresh fruits and vegetables have the least sodium and provide potassium. Sodium and potassium contents of processed foods. Here you can see how the ratio of sodium to potassium increases with processing. The increased sodium and the decreased potassium both negatively impact health, especially blood pressure. Of note, potassium also can help with blood pressure regulation. Sodium deficiency. Hyponatremia, too little sodium in the blood. It's associated with vomiting, diarrhea, and heavy sweating. Symptoms include headache, confusion, stupor, seizures, and coma. Hyponatremia is caused by excessive sodium losses and not from inadequate sodium intake. Sodium deficiency. Please pause the presentation before I reveal the answers and try to answer them for yourself. Chloride. Chloride is an essential nutrient, meaning it is required from the diet. Roles in the body. Maintains fluid and electrolyte balance. It's associated with sodium and potassium. It's also part of hydrochloric acid. Chloride helps maintain the strong acidity of gastric juice. Chloride intakes. It's abundant in foods, especially processed foods. This is the form of sodium chloride and other salts, NaCl. Recommendations are listed. Deficiency and toxicity. Diets rarely lack chloride. As for conditions leading to deficiency, like sodium losses, chloride losses may occur with heavy sweating, vomiting, and diarrhea. Toxicity is due to water deficiency. The only known cause of elevated blood chloride levels is dehydration. Potassium. Potassium is the principal intracellular cation. Remember, cation means positively charged ion, and intracellular means inside the body's cells. Roles in the body: helps maintain fluid and electrolyte balance, helps maintain cell integrity, and aids in nerve impulse transmission and muscle contraction. Potassium is abundant in fresh foods, mostly found in your fruits and vegetables. Processed foods contain less potassium and more sodium. High potassium intakes reduce the risk of hypertension, heart disease, stroke, and related deaths. The DASH diet promotes increased potassium and decreased sodium. Potassium deficiency and toxicity. Deficiency is characterized by increase in blood pressure, kidney stones, and bone turnover. If deficiency progresses, irregular heartbeats, muscle weakness, and glucose intolerance. No UL has been set. Toxicity does not occur with overeating foods high in potassium, therefore, no UL has been set. Toxicity can occur from overconsumption of supplements or potassium salts, or from certain diseases. Kidneys accelerate excretion if given more potassium than the body needs. If injected into a vein, it can stop the heart. Here is a slide regarding potassium in selected foods. Fruits and vegetables are the biggest contributors. Moving on to calcium. Calcium is the most abundant mineral in the body. Adequate intake helps grow a healthy skeleton in early life and helps minimize bone loss in later life. The majority of the body's calcium is in bones and teeth. About 99% is found in your bones and teeth, and only 1% is found in body fluids. Two main roles include part of bone structure, which provides framework to hold the body upright, and attachments for muscles, making movement possible. It also serves as a calcium bank. It offers a readily available source of calcium to body fluids if needed. Extracellular calcium helps to maintain normal blood pressure and participates in blood clotting. Intracellular calcium binds proteins in cells and activates them. Certain proteins in the body combine with calcium and, once activated, allow for actions to occur like the regulation of muscle contraction, transmission of nerve impulses, secretion of hormones, and activation of some enzyme reactions. Calcium balance. Calcium homeostasis involves hormones. The parathyroid hormone, which is secreted from parathyroid glands, regulates blood calcium by raising levels when they're too low. You also have calcitonin, which is secreted by the thyroid gland and regulates blood calcium by lowering it when levels are too high. Vitamin D promotes calcium absorption. If blood calcium rises too high or falls too low, three body systems respond: your intestines, bones, and kidneys. We will talk about this after this next slide. Calcium balance. Bones provide a source of calcium for blood when calcium is needed. The bones, not the blood, are robbed by a calcium deficiency. The blood borrows and returns calcium as needed. Basically, the body maintains blood calcium levels, so if there isn't enough dietary intake, the body will take it from the bones. This chart helps explain what happens when you have low blood calcium or high blood calcium levels. The two slides following this chart help explain what is happening. So on the left-hand side, it looks like the color is purple. You have low blood calcium. So parathyroid hormone gets secreted in the blood. Parathyroid hormone, or PTH, activates vitamin D. Vitamin D stimulates calcium reabsorption from the kidneys into the blood. Calcium absorption by intestines increases, and it stimulates osteoclast cells to break down bone, releasing calcium into the blood. Blood calcium is raised, and PTH secretion is inhibited. On the right-hand side, you have high blood calcium. So when you have high blood calcium, calcitonin is secreted. It inhibits the activation of vitamin D, prevents calcium reabsorption in the kidneys. This limits calcium absorption in the intestines and inhibits osteoclasts from breaking down bone, which prevents release of calcium. Lower blood calcium is achieved, and calcitonin secretion is inhibited. Again, this slide helps explain the process that occurs when you have low blood calcium. And this slide here helps explain what happens if you have high blood calcium. Calcium recommendations. Hormones maintain blood concentration regardless of dietary intake. When intake is low, bones suffer. And the bones suffer because that's where the body is taking calcium from if it needs it. Listed, you see the RDAs. You can see it increases for women after 50 and it increases for men to the same amount after age 70. The increased calcium needs for women after 50 because decrease in estrogen production means less protection against bone loss. Phases of bone development throughout life. Active growth phase occurs between birth and approximately 20 years old. Peak bone mass develops between 12 and 30 years old, so it's usually achieved by the late 20s. Bone loss typically begins between 30 and 40 years and continues throughout the remainder of your life. Osteoporosis versus osteopenia. So osteoporosis is a disease in which the bones become porous and fragile due to a loss of minerals, also called adult bone loss. Osteopenia is a bone condition in which bone loss is significant but not as severe as in osteoporosis. Please pause the presentation and try to complete the matching. Calcium in selected food. So sources include milk and milk products like yogurt, as well as tofu and sardines with the bones are good sources as well. Phosphorus. Phosphorus is the second most abundant mineral in the body. About 85% is found with calcium in the bones and teeth. Roles of phosphorus in the body. It's part of the major buffer system. It's part of DNA and RNA, therefore necessary for growth. It assists in energy metabolism. ATP uses 3 phosphate groups. Many enzymes and B vitamins only become active once a phosphate group is attached. Helps transport lipids in the blood, for example, phospholipids, as well as structural component of cell membranes. Think phospholipids, phosphoproteins. Phosphorus intakes. Commonly found in most foods. Best sources include protein-rich foods like meat, poultry, fish, milk, and cheese. Deficiencies are unlikely, and toxicity is rare. It usually reflects problems like kidney failure. The UL is 4,000 milligrams per day. Magnesium. Where is it found? More than half is in bones. Most of the rest is in muscles and soft tissue. Only 1% is found in extracellular fluid, and that's a reservoir to ensure normal blood concentrations. So similar to calcium, if blood concentration is low, the body may take magnesium from the bones. Roles: maintains bone health, energy metabolism and ATP production. Magnesium has a major role as the catalyst in the reaction that adds the last phosphate group to the ATP molecule. It inhibits muscle contraction and blood clotting. So it works with calcium. Calcium promotes those processes, and magnesium inhibits them. This dynamic interaction helps keep the body in balance. Magnesium also helps support normal function of the immune system. Sources include legumes, seeds, nuts, leafy green vegetables. The average US intake falls below recommendations, may exacerbate inflammation and therefore increase risk for chronic diseases. Deficiency rarely occurs, but when they do, it impairs central nervous system activity. Magnesium has a protective role against hypertension, and the UL applies to non-food sources. Non-food sources meaning supplements and magnesium salts. This slide here is a chart regarding magnesium in selected foods. The notable sources include legumes, nuts, and seeds. Sulfate. Variety of foods and beverages provide sulfate. You can meet your needs by eating a variety of foods. Amino acids. So these amino acids, methionine and cysteine, will provide sulfate as well. There is no recommended intake. Having a normal protein intake should meet sulfate needs, so there is no RDA. Deficiencies do not occur unless there is severe protein deficiency.